Welcome back. Imagine you have a collection of documents related to a specific topic. Let's say recipes. To keep these recipes organized and easily accessible, you decide to store them in a filing cabinet. The cabinet has several drawers, and each drawer contains folders. In this video, we're going to explain the concept of packages. Our filing cabinet represents a Java application. We'll give our filing cabinet, or Java project, a name. We'll call it My App. We have two large drawers. One we'll call Source, or SRC, where our recipes or code will be stored. And another drawer we'll call Lib, where we store the code written by others. Inside each drawer, we'll add folders to neatly organize our documents. In coding terms, the folders represent directories stored in our computer. We give our folders names, which correspond to the package names in our application where we can store our documents. Each folder can have subfolders or folders of folders. In this case, Example is our highest level folder, but within that folder, we have another folder called Recipes and yet another one called Utils. To refer to folders, we use a naming convention. We use dots between the name of each folder and combine them into one long name. Our top level folder is called Example when we need to refer to it. When we need to refer to the subfolders, we call them example.recipes and example.utils. And finally, the documents in each folder are the source code files, the .java files that we create. Back to our recipe analogy, let's say we create two Java files for our recipes folder, one called pizza.java that contains our favorite pizza recipe, and another one called pasta.java that has our favorite pasta recipe. To refer to the location of the pizza file, we use the complete package name dot the file name. So the complete name would be example.recipes.pizza. Notice the case matters for Java. The P in pizza must be in caps. Anywhere we refer to that class, even outside of the IDE on the command line, as we'll see later. Similarly, in our utils package, we have two Java files there as well, one called validator.java and another called formatter.java. Our lib drawer has two files, one called logger.jar and another called api.jar. Jars are simply files that contain code written by others that we want to use in our application. We'll discuss jars throughout this course. Analogies are great for explaining concepts, but let's write some code. We'll create a new project in IntelliJ. Let's keep things pretty simple. We'll name our project My App, and we'll use the IntelliJ build system. Let's make sure no sample code is created, so uncheck the box if it's checked, and let's click Create. We're going to build an application that demonstrates package structure and the use of the import statement. And before we're done, we'll go out on the operating system and look around the file system to see where our compiled code ends up and how we can run it. Let's create our first package by right-clicking on the source folder. We'll select New and then Package. Java uses a reverse domain name by convention when naming the packages for a project. For example, if you work at a company that has the name somewhereawesome.com, reversing the domain name to com and then somewhereawesome should serve as the first two levels of your package structure. This isn't a requirement, but it helps make code namespaces unique. After the domain name, the packages relevant to your application should follow. For our package, I'll add com.beginsecure. Next, we'll add the package names that we plan to use in our project. They are calculator and printer. Let's add each one by right-clicking on com.beginsecure and not on source. You'll know you're in the right spot if you see com.beginsecure. Then simply add our first new package name, calculator, and press enter. Now comes the tricky part. We want to add the next package called printer. We want it to be added at the same level as calculator and not as a subpackage of calculator. So rather than adding it after calculator, let's backspace over calculator to remove it and then add printer and press enter. Now let's add some code. We'll add one class under each package. Let's select the calculator folder, right-click, and select New Java Class. We'll give our class a name of calculator. Notice what happened. It created our class declaration like we've seen before, public class calculator, but this time it added a package name, com.beginsecure.calculator, which is the package name where our code is located. When it's used, the package statement should be the first non-commented line in a file. It's a way to uniquely name classes across your entire application, allowing the class to be referenced and accessed from other classes within the same package or from outside the package using an import statement. We'll look at import statements in just a moment. In our class, we'll add one method. Since we've only seen public static void methods so far in this course, that's what we'll be adding to all our classes at this point. Our method definition will be public static void, and we'll call our method perform calculation. It will take no parameters. We'll add our curly braces. In the previous lesson, we used system.exit. In this lesson, we'll look at other methods from the system class. The system class is part of a package called java.lang. The java.lang package is special. It's automatically imported into every Java source file without the need for an explicit import statement. The java.lang package contains fundamental classes and interfaces that are essential for building Java applications. Some commonly used classes we'll see include object, string, integer, math, and of course, system. So we can call the system class directly and use the functionality within it automatically. Next, we'll say out and then println. The println method will write out a string we supply, followed by a new line character. Strings in Java are enclosed between double quotes always. We'll write the message, double quotes, perform a calculation, in double quotes, and then add our semicolon, and we're done with the code for this class. Now let's add a class to the printer package. Once again, we'll right-click and select New Java Class, and we'll give our class a name of Printer. Notice the name of the class starts with a capital P. As we've seen, class names by convention start with capital letters and are in upper camel case or Pascal case, meaning the first word has an uppercase letter, as does the first letter of each subsequent word. Maintaining standards and best practices is important for writing maintainable code. And we'll add another public static void method. We'll call our method printMessage. Notice the first letter of the first word in the method name print is in lowercase, but the first letter of the second word, message, is in uppercase. This is called lower camel case or mixed case. Variables and method names use this naming convention. No parameters for this method, and we'll add curly braces, and we'll add a message once again with system.out.println. Our message will read, print a message from the printer package. We'll add our semicolon, and we're done coding this class. At this point, we don't yet have a main method for our project. As you know, we must have a main method for our project to run. So under the com.beginSecure package, let's right-click and create another class where we'll add the main method. We'll call it myApp. We'll add our public static void main method, then the parentheses, and the formal parameter list, which is the string args array. So let's start by first writing a message with system.out.println. It will say dash dash begin dash dash. And let's add another println message. It will say dash dash end dash dash. In between our messages, we'll write some code. We want to call the methods in our two classes we created. They are calculator.performCalculation and printer.printMessage. Because these methods are static, we can call them using the class name since the methods belong to the class. First, we'll call our class the hard way, then we'll do it the easy way. To invoke the calculator class, we'll enter com.beginSecure.calculator.calculator.performCalculation. Notice IntelliJ helps us out along the way by guessing what we want to use. And while this works, it's a lot to type. There is an easier way. For printer, let's just type printer, and IntelliJ guesses that we want to use the local one, and it tells us the name of the package it's located in. If we press enter, it will add the class name to our current location and also add an import statement below our package name and above our class. Using the import statement, classes, interfaces, and other types from different packages can be accessed within the current source file without having to specify their fully qualified names. Now for printer, if we just type dot like we did for system, IntelliJ offers us the only available method the print message method. Now let's select that and add it to our code. We're finished coding, so let's go ahead and run our code. And we get our begin and end messages, along with the messages from our methods displayed in between. Let's get rid of the extended name from the package for calculator. IntelliJ offers us a suggestion of what it thinks we want. We can click Import Class to fix the import, and it adds an appropriate import statement, and the calculator class goes from red to black. Let's run the code again, and as expected, it runs just the same. The change to the import statement makes no difference. Now let's take a quick look at Classpath. We'll click on Terminal in the bottom of the IDE. This puts us in a shell on the computer inside our project code directory. If we run the command tree, it shows us our directory structure. At the bottom, we see src and the package structure we just created, com, begin secure, and so on. At the top, at the same level as the src directory, we see a directory called out. It has two subdirectories, production and then my app, and then the same com.beginsecure package structure. Let's see what's going on inside them. Let's run tree again with the /f to show the files. We'll scroll up a bit. Under out, production, my app, we see our package structure with the same files we wrote, but with the .class extension. This is our compiled Java bytecode that IntelliJ created behind the scenes for us when we ran our code. It's the code that runs and actually performs the work when we run our application. How can we run the code ourselves from the command line without the IDE? Java is the command we'll use to run our code. We have to specify the starting location where our class files are located, the directory just above our com.beginsecure tree. We do that with the command line option called Classpath. We can say either java-cp or java-classpath. The location leading from where we are currently to where our code is located is what we need to specify. The location is out/production/my app. Notice I had to use the correct upper and lower case. Even though Windows doesn't care about case, Java does. Now to execute our code, much like how we had to specify the full package name and class name to our code to invoke a method, we have to provide the same information to reach the class with our main method in it. This is called the fully qualified name. Our main method is located at com.beginsecure.myapp. Notice there's a space between myapp and com. Again, be careful with upper and lower case and use dots, not slashes. And when we hit enter, our code should run. Notice we don't add the .class extension, just the name of the class file. Because our class files are all present and in the right location relative to our specified class path, as well as one another, everything runs fine. We'll look at zipping up our project code into jars later in the course. The value of Classpath can be set globally with the Classpath variable at the operating system environment level. But this is not always available for you to change as a non-privileged user or in production, for example. Specifying the class path as a command line parameter unique to your application can often be less error-prone and frustrating to use than relying on the system class path. Let's see what happens if we mess up either the class name or the class path. First, if we change the name of the class we want to run from myapp with an uppercase M to myapp with a lowercase m and run it, we get a runtime exception. Notice it is very helpful and says the name is wrong. If we correct the app name, but change the class path to be wrong, and then run that code, we get a slightly different runtime exception. This one says class not found exception. Maybe not as helpful as the first message, but it will at least give you some direction on how to go about solving the problem. All right, that's all for now. Thanks for watching, and remember to always begin secure.